Hi everybody and welcome back to the second part of this first video. Again, it's a data analysis project in Python where we try to follow the ChatGPT trend on media and its interactive visualization with other topics. Now, this is where we ended last time. Today, we're gonna focus on the next two libraries, Spacy and NetworkX. For those who never used Spacy before, a few words about it. Spacy is a natural language processing library. That means a lot of things. To sum up all its main features, it allows users to analyze some input text and extract a consistent series of information from it. Moreover, if interested, you can even train to try to create new words and vocabulary. But for now, let's just keep it simple and see how to use it for our today project's purpose. Okay, and the warm-up, now let's get it started. For explaining these two blocks of code, we'll better start by understanding how Spacy works. Everything starts by two elements. The first one is an input text. In this case, it's the column of article titles from our previous data frame. Second element is a pipeline that is used to process or analyze that input text. To import a pipeline, we run this line of code. And if you can't load it, relax, because you first need to install it. And finally, let's see how do we combine these two input elements. Imagine this is one of our article title texts, taken from the data frames we previously created. For working with Spacy, we need to use this input text and let it be processed by a pipeline. That means that each element with it undergoes a series of functions included into the pipelines. The process of breaking the text down and its analysis is called tokenization. And that it's basically the starting point in Spacy. Now, to understand what these pipelines do, just take a glance at Spacy's official documentation here, as a summary of what just said. As you can see here, a pipeline applies a list of functions, such as a tagger, a lemmatizer, a parser, a name entity recognition, and so on. And let's say that a series of words or text are pre-installed, so we speak of a trained pipeline. In the official page, you can choose from a lot of trained pipelines. In our case, we just uploaded a small data frame database of English words taken from the web. Last but not least, by importing a pipeline, we get access to a series of grammatic, semantic rules to recognize entities, labels, tags, and so on. Finally, the output is the same text we start with, but now it's become an object. An object is a series of words. Each words are equipped with all the new infos we just talking about. So, to inspect what there inside these new doc objects, we need a for loop, as the one we're looking now at the second part of the block code. Alright, now we know what a pipeline is and what it is used for. But what if I only want to concentrate on a bunch of words? For instance, specific terms strictly connected to the ChatGPT and AI world? Well, this is what I've done as a first step. Among all the words and entities that this upload pipeline can detect, I want it to select a few of them, and at the end of the story I added a specific label name for all of them. The specific name is Skynet. Well, I thought it was appropriate. And finally, let's see what we got when we run this code. As you can see here, I ran the code and this is the output. As I told you before, we now have as output a documentation, so an object, and this object can be inspected by a for loop. In the for loop we got several dimensions nested. First one we got sentences, and among all the sentences we can find the text or label. We can even find some other information. For now we just append this in a data frame, this into information, text, label, and sentence, and that's the output. As you can see here, we've successfully managed to making it recognize Skynet as a label and find out other words, for instance, AI, UK, OpenAI, ChatGPT. So a list of words coming from different kinds of typology, from the geography, political, to the artificial intelligence. So now let's see what we're gonna see now is showing the same information we just talking about in a more cool way. For instance, for E in ChatGPT.doc, we can displace it.render this final documentation. The style just the entity. You want to show all the entities recognized, and that's the result. As you can see here, it's funny and colored. We find some geographical or political name like Chinese in color. ChatGPT is another. And as you can see here, Skynet, it's the same color because it's a label recognized for these two words. Probably there's another, for instance, AI, Skynet, it's in gray, and so. We successfully imagined in just a couple of commands. And that's it. Now we're ready for the next part. Okay, that's what I call a bonus track. And I'd like to share with you in this bonus track another funny way to represent words in Python. For this very first step, I'll use the WordCloud library. It's a very common and very popular library, so in case you have never used it, just take a glance at the feature documentation. Anyway, nothing complex to explain here, just follow me while showing you these few lines of code. From the database just created, we just fill in two lists, the first one for the entities and the other one for the labels. I use extend command instead of append because this way I could copy each element alone from every row's list. What that means is that, take a glance at here the data frame. Each column has a series of values into a list. So for each rows, if I use append, I will use copy and paste a list of values as a whole only element and doesn't allow me to copy and paste OpenAI as a single element, Elon Musk as a single element, and that's what I needed. Okay, perfect. Now I want to say Python to exclude a list of words that I don't want to show in my plot. That's called they don't have anything to do with ChatGPT or AI world. Okay, these words, as you can see here, are John Norton, Australia, Turkey, but you can choose as many words as you wish. So just customize according to your tastes. I use an enumerate for loop and then I exclude these words with a pop command. Nothing to explain here, it's a normal for loop. For those who never use enumerate, just pay attention to the fact that here, for excluding some words and don't have any problems, I need to work on the single position of the index. And that's why I use J and Y and I. Okay, so last two steps are creating an image object, and for this I use the generate command. As you can see here, the words I exclude now belong parts of an object set, and I can update each word I don't want to show every time I wish, just with update. Okay, now nothing to say here, just remember that apart from the customization, the colors, the contours, whenever we want to use a background, as in this case, I want to show my plot in a background with a specific shape. In this case, I want the shape of the ChatGPT logo. For doing that, I need to create a mask. This mask is just an image that I open with image.open. Pay attention, the image, the PNG, is in the same working directory as you working. Okay, once we're done, we need to transform it with an empire array because that's the way it works here. Finally, we can plot this image with to_image and show, and that's what we got. And our final output is a pure disappointment. What I'm talking about. Here on your left, you see what was supposed to be our final background shape, so the ChatGPT logo. Unfortunately, we got this on our right. That's the actual output. Okay, the shape didn't work for some reason. I don't know why, but it didn't work. Anyway, all the rest is correct. As you can see here, the ChatGPT name word, the AI and OpenAI are the biggest words inside of it. And that's correct because they represent the number of occurrences inside our data frame. And of course, these words, as are the closest one to the ChatGPT word, are the most popular. Unfortunately, it didn't work for the shape, but trust me, I did it many other times in the past, and in each attempt, it got the job done. So just try yourself and maybe you'll be luckier than me, probably luckier than me. Now, move on. Before switching to the NetworkX, we need to see something else. Okay, that's a pure Python coding basic section. And this is something we need to do before moving on to NetworkX, especially for this last part of the outcome you're watching now. On the left, we got a plot which is a counting of the number of occurrences for each entity alone. On the right, instead, we got the most popular couple of pairs of these entities. So AI and ChatGPT is the most popular one, as well as ChatGPT and then AI are the most popular ones on singular. So we got on the left what we call series, and on the right what we call the series combo or combo series, don't remember, series combo. Okay, let's see how we did it. First of all, let's start from here. Okay, I'm gonna to uncomment this section because I need to show you how we did it. Let's start with list words, okay? And let's see what we got here. As you remember, this is a list of all the entities recognized. If I count all these elements, and that's what I want to do here, I got these things, a key and a number of the values. I use items because now I created a dictionary of them, and I need to count these elements alone. Okay, so if I want to sort these values now from the most popular one, I just use sorted, and once again that I got to use items. I just summarize these three lines of code. Okay, for this reason I use items again, and the key value are the numbers. Okay, and so for those who never use this trick, let's see, we're gonna use a lambda x function where x is the second element, so the number. And finally, we use a reverse order. Okay, I think I've done everything, and that's it. So this is the results of these lines of code. And uncomment now, and see. Okay, this is most ordered. And the same thing we're gonna do here is for the right one. But before doing it, we need to create our combination, and that's what I did here. First of all, let's start to understand what is df entities here. And we see there is a list of values for each rows. And that's important because we need to work on now combination for each rows, 2 by 2. Okay, and once we've done it, we want to append these values 2 by 2 on an empty list, which is combo, and count it. Okay, so this is the meaning of this part of the code. And let's see what happens here is this one. Okay, are not ordered yet because now we need to do something more. I need to avoid to count the combination of words which are duplicated. And sometimes they're duplicated because there's an inverse order of the words. For instance, I can have Microsoft and ChatGPT or ChatGPT and Microsoft. For not counting them twice, I use this one. First of all, and I always suggest you to do that, this trick, use a checklist. Now I'm going to use set instead of list, which is almost the same thing, but set doesn't allow for duplicated. So this is what I've done. I created a list of duplicate where I put all the duplication number, and then I keep on only the what I need. And once again, I ordered that in a dictionary. I use ordered dictionary instead of dictionary for one reason, because it allows me to conserve and to keep the same order after I use an iteration with this instrument. If I had used dictionaries alone, there will be a lot of problems. But we need an ordered series of values for our combos because we need to plot as well as they are. So this is what I've done here. And finally, I make two plots, AX0 for the left, AX1 for the right, and I customize all of them. And that's what I've done. Okay, now all we need is just the right one, because we need to use it as input values for NetworkX. I'm just spoilering some information now, because now all the keys, AI, a ChatGPT for instance, are a couple of values, a couple of what we're gonna call them as nodes, and this is the basic of NetworkX. Let's see what I'm talking about. Alright, we get a data frame with our entities and labels. We've seen some bar plots, but now it's time to focus on the relationships between the data of the two columns. And here comes the use of NetworkX. Why? What is NetworkX and what is it used for? Well, to sum up, NetworkX is a library that allows users to manipulate a big number of data and visually inspect their relationships. Generally, they're presented like clusters, or, as the name suggests, networks of points linked to one another by lines. To make it easy, NetworkX starts from one or more points called nodes. The very first node is called source, while the landing one is the target. They may represent whatever kind of data you want, for instance, people, letters, animals, numbers, and so on. Then, these points are linked to each other by a connecting line called age. This line includes a series of attributes representing all kinds of features for each pair of points. Okay, we can finally jump back to the code. In this part, I start with a series combo, what we found out in the previous part, which is a series made of 3 columns. The first one, they may be regarded as the source points, as we already seen, and they are the first name of the couple of entities we find out. The second one is the source points, so the ChatGPT, okay? And the third column are the attributes, so the values of the currencies for each pair. This is important to define these elements, because now we need to provide and create a plot object that we need to be displayed in NetworkX. First of all, import NetworkX as NX. And how it works? First of all, we need to find out a pandas data frame. This is what we create from our dictionary. Okay, this is a specific command which works better in this way. So we create a pandas data frame starting from this dictionary here, which is the series combo. And we rename the columns. The first one as node A, the second one node B, so the first one is the source, the second the target, and the values, which are the attributes. Okay, now we got here, we can create our plot objects in NetworkX with the command NetworkX from pandas edge list. So we provide them with our data frame, with source points, which are those in the columns node A, target, node B, and edge attributes as values. But we can even provide as many as attributes we want. In case here, in the last part, in the last column, we got a series of a list of columns, which are the attributes. But for now, let's see that. Before plotting, let's inspect what we got here. If I say g.nodes, I can see all the nodes, so all the elements, all the entities recognized by Spacy, and then now I store in my data frame. AI, ChatGPT, and so on. Other information, useful information that I'm going to show you before move on is the ages. And so now we have each pair of elements, which this pair of elements are the pairs of our points, source and target. And finally, we can decide to inspect which are the values or all the attributes for 2 specific points. In this case, I want to choose ChatGPT and OpenAI. Okay, and let's see what we got here. Then values number 2. But as I told you before, in case we got a list of values, we can inspect a list of attributes. Now we're ready to plot it with the command nx draw NetworkX, and I want to show even the arrows. Once I'm done, this is the final results. And the final results are really disappointing, because as you can see here, it's a static object. I can only see there are some outliners here in the bottom and in the top left, and something like a huge cluster of data. As you can see better, we have 3 specific subclusters. So a specific cluster of points surrounded, which are surrounding 3 core nodes or points. Let's see what, in order to see better this way, I need to use another instrument which is strictly connected to this library, so to NetworkX, but it's called PyVis. PyVis works with, as input data, with dictionary. So first of all, I want to see this thing here, just to show what I'm talking about. I need to understand which are the number of degree of this plot. What does it mean, degree? Degree is the number of edges which come or pass through a specific node. So all the adjacent, all the points connect, all the edges pass through to a specific point. And so I can see here, AI has 28 of these edges, ChatGPT 49, which is remind us that these are the main core, as you see here, the main points which are surrounded by all the other clusters of points. Okay, and now if I want to put in order, I can use the same specific lambda function I did before and see now in the order. ChatGPT, AI, and OpenAI are the 3 basic clusters here. Okay, and now let's plot it. For plotting them, so I first of all add this information, I say, so the number of degrees, and I set node attributes. So these are attributes that I need to add to my G-plot. G is the object, the graphical objects that I want to show in NetworkX. And I want to add these attributes here, but I can add as many attributes I want, for this, like the color, the size, or whatever information I need. So it's up to your fantasies. For now, I just want to add this information here. And I call them sides, because then when we want to inspect, like I did here, I need to find out the right name. And so on. Now I create a network object, which is the same as NetworkX object before. I make my connection between network and NetworkX, and finally I can show it. If I click here, nothing happens, because this is done and properly done for Jupyter Notebook, even if it's an IPYNB file. In order to use it in Visual Studio Code, as I've done before, as I've done here, I really need to find the same directory I'm working in. So now my file is in, then I could save it as skynet.html, and I can open it in another browser, for instance. Okay, and this is what I've done here now. This is the same plot I saved, but with network, not NetworkX, but pyvis.network. And so the same information, 3 basic cores, and now I can zoom out, zoom in, and prepare for the most cool thing. I can move this information in order to, well, just as in my case, just for getting fun. Okay, and we're finally ready for the last part, where we're gonna raise the bar even further by splitting and hosting points into 3 main groups. Now, let's pretend I'm in a data analysis department, and I'm working on a more complex database than this one. However, my information are plotted the same way. I may be asked to find more deep insights. For instance, they may be asked to classify all these nodes and separate into specific clusters. That's the concept behind the community library that I'm going to show you right now, this one. It's a built-in function inside the NetworkX library, and I'm not going to explain you right now the math behind it, because it's far beyond the task of this project, and more especially because it's time-consuming and it's pretty complex. However, the task of this project is pretty simple. We're going to create some partition, or better, groups, as this one at the beginning, and we classify our data as belonging to specific class. So the yellow one here is a class, the red one, the green one, the blue one, there is another one. So my data are classified according to some algorithm inside these main groups. And now I can do the job, as I told you, within the network function Louvain communities. However, it's a bit disappointing, the results, because it's something like this. Another static project and a plot. Thanks God, once again, I can do the job done by making it interactive and by using the community API library. Please pay attention, because even if the name is community, you got to install as Python Louvain on Pipeline. Okay, now nothing to explain here, just the code. It's very short, and once again, the overwhelming majority of the code here is the same as done before. The concept is pretty easy. First of all, I create my group, and the result is a dictionary. The dictionary is important because, as we've seen, it's the input data we need to provide when set new attributes, because we need to provide new information to plot in a NetworkX. Then we will create an interactive object, and we link this interactive object to our data frame and our G, which is the plot object in NetworkX. Finally, we exploit it by using the same directory we work in and show in a browser if we're not using Jupyter Notebook. And that's the results. Okay, this may be done for a series of reasons. For instance, imagine this basic group, or the big group of clusters belonging to some specific region, continents or country regions. And I want to find some specific keys because they are a connection between these markets. And so I can focus on specific marketing advertising or a campaign in order to hit these links, these key customers. That's just a mere speculation, but maybe be something. Hey guys, did you realize that we missed the label columns to be used? And that's the reason why I added this part, the very last part of the project. Starting from the beginning, do you remember that we pass our web title columns of our data frame, original data frame, into our pipelines, and we got this documentation. That's the same I'm showing you right now. So a series of articles of text. Each text is now a document, so an object containing entities, sentences, labels, tags, and so on. And now what I want to do here is plotting all information, all nodes, as sentences, as entities, as labels, and section. For instance, ChatGPT can be used inside a lot of other sectors, for instance, technology, of course, but even opinion. Here we got Australian news, education, and so on. Now, I want to have a perspective of how popular is this, the word math, according to ChatGPT, and how it's spread over all series of sectors of our life. And that's what I've done here. First of all, as usual, I use enumerate to separate all the documentation for each sentence, so for each articles and titles. And I want to store, as done before, the entities column, the labels column, and the section. The section was taken from the original data frame we downloaded with the API. And finally, everything is stored inside a vocabulary and then a data frame. This data frame is the one you're looking here, and only elements which are not null. Once we're done here, I want to do this new list, the first one for the sector, so I inspect a for loop for each element on the section. And then the other one is for the entities. As you remember, as you can see here, each row has a list of elements, so I gotta do a second for loop inside the square bracket. Nothing special, nothing new. What is important here is that in NetworkX, I want to display nodes as separated and unique elements. For this reason, I use entities plus sectors as a set. And I use a list because when I want to display, I need a list. In this way, I got all the nodes available at once and not counting them as duplicated. Finally, a list that will append all the section here as unique. For doing that, I need to use the zip function for entities and section. This way, as you can see here in the list, I can have first element, this one, this list. Second element, this element here, opinion. And for having Elon Musk opinion, OpenAI opinion, Keenan Malik opinion, I need to make a for loop. And that's what I did here with not enumerate, but a nested for loop. Once I did it, just the results. So as you can see, Elon Musk opinion, OpenAI opinion. So now every information is stored correctly, because as you know, each node must contain separate attributes. A lot of attributes. Each attributes must belong to specific information, so not duplicated and so on. Finally, we can graph in the same way. First of all, add nodes from our list, okay, and I label them as section and entities. Once I've done it, I had to use this specific for loop in order that my labels are stored correctly and not to use any duplicate once again. I choose my layout, and finally I can draw. Instead of using just NX draw NetworkX, I use several nodes, several plots. First one for the nodes, color line, and for the list of entities. Another one for the dark violet for the nodes of my sector. Then I even have the edges, so all the edges, all the lines are gray, and finally the labels in yellow. The final result is this one. The insights are pretty evident. Technology was supposed to be the field where ChatGPT had the most of the occurrences, and in fact, look at how many points, how many nodes. And opinion is not the popular one. Business and education, we're expecting something more, but it's pretty coherent with our data. Of course, it's not a very meaningful data frame you can download from many other sources, much better sources. Just a look at the colors. In greens, all the nodes. In purple, even if you cannot watch properly, are the nodes for each sector, and the yellow for the labels, as we set up. And that's the end of the second part of my first project. I would kindly invite you to remember it was my very first attempt ever in making a video. So, thanks for your patience. I hope I've been helpful along your personal adventure inside the data analysis world. Hopefully, I will upload new videos relatively soon. So stay tuned, and in the meantime, in case you wanna comment, like this video or subscribe to the channel, you're definitely welcome. So ladies and gentlemen, thanks for your attention, and see you next time. Bye bye!